All right, I got the right screen here. Look at that. Now you can actually see the screen. All right, so we're going to talk about the Stacks and Queues project first. We didn't actually really use a deck at all, but it was there, just Stacks and Queues. And then we'll get into the linked objects next here. So we fire up PyCharm and project. How'd this one go for you, folks? Cool. I know we had a little extra time on it, just because things are a little crazy. So hopefully that worked out well. Let's see. This is project 2. Now, there's a couple different ways we could go about this, because the way we want to design it is going to impact like how we go about it here. So I'm a big fan of classes. We didn't really need to use any classes for the solution part. We want to use our stacks and queues. So we go grab that real quick. Oh, I got it right here. So we'll do our stacks and queues. This was a while back. So we wanted our linked stack and linked queue, I think, right? These were fine. Yeah, the queue was good. We'll go add these in here. So let's go add a new module here. So this is our structures, something stack and queue. So add in the queue, and then we wanted the stack. And then the linked stack, I think this one was fine performance-wise, right? This was good. We can put them both in here. I think that should be fine. From stack and queue, import stack and queue, the linked queue. Why does it not like stack? What did we do wrong here? Oh, I missed top dot item. I must have missed that in the copy paste. Is that in there? Oh, yeah, yep, that's just a bad copy paste. All right, so now does it work? Come on, red line, go away. Was it linked stack? Oh, it is linked stack. There we go. Linked stack. All right, so we needed to unload, and then we needed to load these things. So as we're thinking about how we go about doing all of this input and output stuff. So I like using classes. You didn't have to. So I'm going to make a class for the doc. And the doc will be responsible for doing the unloading portion here. And then it will create the stacks and queues needed for the planes and trains. Again, not entirely necessary, but I like how this kind of breaks it up here. So I'm going to add a class for doc here. And then we're going to have our init method here. So to create a doc, we need to give it a couple things, right? We need to give it the information it needs here. So might as well just take a couple lines of input then. So if I take my numbers of planes and trains, right? The train items, the plane or the number of items for trains, number of items for planes, train items, and plane items. I can take those 5 pieces of information and I build the doc and set it all up. So again, either way you want to go about it here, but I like just accepting that information here. So this is my numbers, planes and trains info, trains, planes info, maybe the first one, and then we have the number of items for trains, and then the number of items for planes, and then we have the train items, and we have the plane items. Right, so we can just give it all those 5 pieces of information here as we go. It's a little long here, sorry, but plane items, there we go. And I can start creating these things. So if I know how many trains and how many planes I have, I can go set up this list of trains and planes. I'm going to have a self.trains list here, right? It's going to be a list, and a self.planes list here. Then I can go and make that many trains and that many planes, right, as we go here. So, and then we can start setting all the items we have for each one here. Now, we don't actually really care too much about this number and this number. If we wanted to go and validate, we could go validate. Oops, I forgot to open the stream up here, sorry. Pull it up on the other screen here. Make sure I'm not missing anything. Let's see. Okay, cool. Not missing anything there. So I'm only going to look at those first numbers, and really they should be equal to this number of items here as well. So we could probably even just forget this first line of input, because we can get all that information from how many are here and the sum of all of them. Right, so that's an option. Right, doing some sanity checking would be nice, but really we can just ignore it here and just get rid of it. I only need really those last 4 lines: the number of items for trains, number of items for planes, and then the train items and plane items. Everything else I can derive from there. So we'll set trains and planes, and then I can say now this is going to be probably a string input, right? And again, depending on how we wanted to handle the input and translating it, if we want to split it and turn it into numbers, we've got all sorts of options here. The easiest is just to give it as it is as a string here. So I can say for item in number of items in trains, and then we can split this, right? And by default, split's going to split on spaces, which should be good. So we can just take each one of those things here and go. So for every item, then I need to take that value, turn it into an integer, and then store it as a plane, or this one is a train here. So we need a class for train. And to store that information in train, I need to know what the number of items expected, or max number of items, or something like that, right? And then I can say self dot current number of items is 0. Self dot number of items expected is the number of items expected, right? And I also need to know a time fully loaded. Probably starts at 0 till I know otherwise, right? And again, we can figure this out. We don't have to use classes for this, but I like this idea that this class represents something here. Okay, so I can make a train then. So I can say I want to take my self trains, and I want to append a train given the integer value of my item, right? So that should be the number of items for trains, right? So the first one will be this number. Now I probably also need to know the train number though, right? Because I should know what my number is. That's useful information. Might not be necessary to have it as part of train, but I think it's useful here to have it as part of train. So we have a train number, and we probably have to pass that in then, right? So we have a train number. So we want to start train number off at 1, right? Train number equals 1. I can give it the train number, and then take my train number plus 1. So train number 1, this first one, train number 2, on and on and on and on we go, right? And we basically do this exact same thing for planes. This is number of items for planes, split. We need to make a new plane, given the train number. This is the plane number, right? Plane number, plane number, and plane number. And I need to make a class for plane. Now, if I'm thinking about train and I'm thinking about plane, it's going to have the same set of attributes here, right? And you know the good rule of coding here: if you have the same code twice, you should feel bad about yourself. I don't want to do that, right? So what could I do to make them share? Well, really, this is just a transport method here. But what the transport method also knows then is its multiplication factor, right? For a train, the distance for one way is just its train number. For a plane, it's 5 times its plane number, right? So we could take that in as if the only thing is different is how much time it takes to get there, we could take that as an attribute. We could take a distance, what do we want to call it? Distance factor, distance multiplier, or time multiplier, distance time multiplier. See, that sounds awful though. Multiplier, distance, time. Okay, sure, why not? And we can have that attribute, self dot distance time multiplier is my distance time multiplier. So I make a train then, its multiplier is 1. When I make a plane, its multiplier is 5. And they're all just transport methods now. Everything else about them is the same, right? That's one option. Again, we don't necessarily have to do it this way, but this works out pretty nice here that I don't need to rewrite the same code twice. Okay, so now I've got all my planes and all my trains, transport methods lined up, ready to go. And I feel a little bad having these numbers here, so I might want to make these as attributes here. So this might be my train distance time multiplier, and then a plane distance time multiplier. This is probably better, right? You want to put nice names to what's happening here. Self dot, there we go. Now we're putting a nice name to that number here, so it works out pretty well for us. We'll make all of our trains and planes. Now we need to go and load all the items. Right, so I'm going to have a self dot. This is my train queue of stacks, right? Equals a new queue, or a linked queue in this case, right? And then I need to go and process all the train items. Right, so I'm going to make a stack first. So this is a stack equals a linked stack. And then now I'm going to loop through every train item. So for item in train items. Now I really need that as an integer though, or so train items dot split. Sorry, right? We want to split that, split. I want to get my item as an integer here, or the train location, I guess, right? Train destination train is an int of my item, and that tells me what place it's going to, and then I want to add it to the stack. So we'll take my stack dot push, and we'll push the destination train there, and then I need to check, is there room for it? So I know the very first time it's going to fit, so I know I'm going to check afterwards. I guess we could check beforehand, but I think either way should be okay. I'm going to say, hey, if my stack dot what is it, length of stack is greater than or equal to 5, I need to add it to the queue. We'll take my self dot train queue of stacks, and we're going to enqueue the stack. Then I'm going to make the stack be a new linked stack, right? Give me a new place to store things, and do this for every item. Now, if you spend a little bit of time testing this, you're going to run into, if you don't have an even number of 5, you never queue the last stack. So after this is all done here, we want to make sure that if the length of stack does not equal 0, we can queue that last stack, just in case. Right? And even queuing an empty one's probably not the worst thing in the world, but this is a quick little check, because we might not have had exactly a multiple of 5 number of items for these trains. Depending on how much you tested it, if you used up different values to figure it out, you really ran into that. If you used ours, then it's fine, you wouldn't have seen it, but that does affect if it works or not. So we go add it to the stack. If we have 5 or more, put that stack in the queue. And really, it could just be equals 5, but just in case something weird happened, I'll say greater than or equal to 5. I don't think it matters at all. We should never get there, but we got an option. Now I think, does stack have a length? It doesn't. Oops. If we can't use length of stack, then can we? We've got to add something here. So let's see. So we can add a self dot number of items is 0. Every time we push, self dot number of items equals 1. When we pop something off, self dot number of items minus equals 1. And then we can add the length. Find length, turn self dot number of items. And the queue probably needs that same thing too, right? So we should add in that for queue. Oh, does not belong in node there. There we go. No wonder it was upset with me. I wasn't suggesting it. Yeah, in our init for stack. Okay. We'll do the same for queue. Self number of items, define a length. And then dequeuing should take my self dot number of items minus 1, and enqueuing should add 1. Self dot number of items plus equals 1, right? Then we can deal with our length here. That should work out a little nicer. Okay. So that takes all of the train items then. Now we have to do the same thing for plane items. Now for plane items, it's pretty easy because we just go into a queue. So self dot plane items queue equals a linked queue. And for item in number of items for planes, nope, plane items, dot split. Take our self dot plane items queue nq and int of the item. Turn it into an integer because we need that number here. That's it. So now they're all queued, ready to process. These are all stacked and queued, ready to process. So that should work. So if I give it those 4 values, we should have the doc ready to go. Well, now how do we load the item? So now we can have a method for load. If you want, you could do it all in a init, I guess, or you could make this separate. I don't know if it has to be separate, but I like the idea of it being separate. I don't know, or load planes could be separate from load trains, or I don't know, any way we wanted to do this here. Load items, maybe. And maybe this one would then call load planes and load trains, or any way we want to break it up is okay. You can make gazillions of method functions if you want to. This should be okay. So if you do the trains first, so if we want to do trains first, we're going to say while my length of self dot trains queue of stacks does not equal 0, right? As long as I have something in that queue, I'm going to go work it. So I can either work it right off the front, or I can dequeue it and work it. Both should be fine here. I think it's probably easier if we dequeue it when we're done, because that way this while loop can run and we can just take whatever's on top first. So we know this is only going to run here. So this will be the, we need the time here. So current time is 0. So I'm going to take the number off the front stack here. So I want the, destination is going to equal the self dot train queue of stacks front dot peak. Right, we should be able to peek at the stack. It should give me what's on top. I guess we could just pop it off too. So if it's not empty, I guess we should make sure it's not empty first. So if the self dot train queue of stacks dot front, so if the length of that, that's right, we don't need that extra parentheses here. The length of whatever's at the front is equal to 0, let's dequeue it. Self dot train queue of stacks dot dequeue. So if there's nothing left, right, the front stack, if it's empty, get rid of it. And if it's not empty, right, then we can start working that item. Right, and then this way we'll just come back to our loop and see if we're done or not here. So if it's not empty, then I'll have my train destination is going to be the top of this. So front dot pop, we'll take off the first item. Whatever's on top of the stack, let's take it off. That's my destination. So to get there, then I'll know it's my current time plus this number times the load factor. So we need some way of getting the time distance multiplier. Or if we want here, we can have a function for something like load item. So to load an item then, it's going to, we don't actually care what the item is. It doesn't matter here, but how about if you tell me the current time, or the start time maybe, start time, there's an M there. So if you tell me the start time when you started trying to load this item here, I can check and add to my current number of items. So I'll take self.current number of items plus 1. And then if my self.current number of items is equal to my self.number of items expected, then I know I'm fully loaded. So this is my time fully loaded, then is going to equal the start time plus my train number times my time distance multiplier. Right, so if I'm train number 1, it just took 1 minute, right? And now I know my time is fully loaded. If I'm train number 5, it took 5 minutes to get there. If I'm fully loaded, was whatever the start time was times 5. Or I'm sorry, plus 5, right? So train number times the time distance, which is 1 for trains, 5 for planes. Add that to the start time. That's the time I was fully loaded, right? Or maybe this is instead of start time, this is time worker left dock with item. How about that? That's even nicer, right? You know exactly what we're expecting here. The time the worker left the dock with the item, right? And then when we're done here, we can return the time the worker left the dock. All of that times 2, because it's the round trip, right? So should we say this is a one-way? I don't know if that's more useful for naming this. So I'll return the time to you. So you tell me what time you left. I'll tell you what time you got back, right? So this way, all that arithmetic is happening based on the transport method, knowing its number. I guess that shouldn't be train number. That should be, I don't know, position number, maybe? Let me refactor that. So right-click, refactor, rename. This is position number. There we go. Right? Why is it not like this? Distance time. Oh, because the line's too long. That's fine. We can load the item. So cool. So as long as there's an item, then let's go for it. So I'll take current time, and it's just going to give me the value back, which is nice. So I'll know the new time. So current time will equal my self dot trains index of the train destination minus 1, right? Because remember, we're going to start at 0 for train number 0 or train number 1. So if we take 1 away from that, train destination dot load item, and we need to give it the current time. We'll go load the item on whatever train it is, right, based on that destination, and then we'll reset current time to whatever that new value is. And then we'll go back. If the length of the queue of stacks is not 0, then let's see if it's empty, dequeue it. If not, work that top thing. Eventually it'll dequeue it, and then we'll go to the next stack. We'll work all 5 items, we'll dequeue it, we'll go back, we'll work the next stack. Right? I think this takes care of that for these ones. And then we're going to reset current time, go back to 0, and then we can say while the length of my self dot plane items queue does not equal 0, we'll do the exact same thing for planes, right? So we'll get the item. This is the plane destination. Right, is going to be we're going to dequeue from there because we know it's not empty. So by self.plane items queue.dequeue, and then we'll take current time equals self.planes, right, at index of my plane destination minus 1, load item, given the current time. Right, does that work? Plane items, right? Don't we have planes, or no, planes, plane destination minus 1. I don't know why I didn't pick up the load item like this one did. That's fine. This one's a little easier. It just works. It should, right? Because we told it what the load factor was. It should give us back the new time. We just keep on going as long as we have somebody to in the queue. And then when we're done, right, the idea was getting the output here. So it should load items give us the output. You could do that. So we need a result. Here's going to be a string. Probably easiest here. Then my result, I can set, I want to add to it here. I guess we can do trains first, right? So we want to take every time that the plane was fully loaded, the time fully loaded here. So we need a way to get that. If we're saying this is a private value, we need a way to get it publicly. So we'll add a get time fully loaded, turn self dot time fully loaded. Right, now we have a public function to get at that value. It's good. So we could do a list comprehension if we wanted. Should probably work out because we would just want the values here, right, with nothing in between them here. Nope, don't need Firefox open. Close Firefox. Okay. So I need all of those values. So for train in self.trains, and we want really the train dot get time fully loaded. Oh no, for train in trains, the syntax always messes me up here. We want goodness, train dot time fully loaded for train to self trains. Is that that's going to be okay? This is not going to work out as pretty as I want it to, because now we need to make sure they're separated with spaces. So we want to do a space dot join. Right? If we join them all together with spaces, and we want this as a string value, right? String of that. Are my integer parses wrong? I need to do the other, int side. Okay. Right, so the string version of the get time fully loaded for every train and self trains, joined together with spaces. I think that'll work. Then we take our result plus equals a new line, right? And then we can take my result plus equals my plain get time fully loaded for plain and self planes. We can return the result. I think that'll work. It might. We'll try it and see, because this syntax is a little funny here. Right? Again, you didn't need to use classes here. I like this idea, and it helps us reduce the amount of code we need. Because really, this is exactly the same logic every time. No matter if it's a plane or a train, it's just based on its distance and time multiplier. Let's try it and see. So we'll make a new doc, or I guess we can get the input then, right, if we want, from the user. So we can have, this is, I don't know, throwaway line with an input, and then this is my train items, or no, number of items for trains, number of items for trains equals an input, number of items for planes is an input, my train items is an input, and my plane items is an input, and then we make a doc equals doc, given the number of items for trains, number of items for planes, train items, and my plane items. And I'm going to call doc.load, load items, and we should print that. Right, what do we get back from load items? Should do it, I think. Should see if it works. So it needs some input. We didn't prompt for anything. It would be nice to prompt for some of that input, but I should be able to copy paste all this in here. Nope. Paste. Oh goodness. I broke it. Hang on. Run. Hit copy, right? Copy. Paste. Oh goodness. All right, well, we missed something here. Plain item, transport method, plain number, transport method init requires 2 positional arguments. Requires 3 positional arguments, doesn't it? 1, 2, 3. Oh my goodness. I have parentheses in the wrong spot here. Right? There we go. I was ending the transport method init early. That's why. Let's try it again. We gotta go copy paste again. Right? Oh, list index out of range. Interesting. The plain destination -1. Interesting. Did we screw that up somewhere? We must have, right? Where do we break that then? So my train, self trains append and self trains append. A bad copy paste. That's what's going on here. Planes. Copy paste is dangerous. It's very dangerous. Try it again. Uh-oh. 0, 0, 15. That's all we got. Something didn't work right. Oh, I think we have too many spaces in here. That's why. So let's go to Notepad. It's my input. Yep. I gave it a bunch of empty lines. Try that again. Right. Node object is not callable if the length of train queue of stacks front equals 0. Length of the train is a linked queue. The linked queue front dot item, right? Front should be is a node. None object is not called. Is my Q class bad? Q class might be bad. Did you guys use the Q class? I think I used a bad Q class. I don't have the doubly linked deck. I think it worked, didn't it? Gotta be something in Q then, right? Let's see. Front and back, number of items, front item. If front is not none, if it is none, set front. Otherwise, back is a new node. Back is the new node. That should be fine, right? All right, well, let's try it in debug mode. Let's see what's going on here then. So let's, it's going to be my train queue of stacks. So maybe we'll just put it here and watch what happens. All right, paste some input in. All right, so number of items for planes, number of items for trains looks okay. Plane items, train items looks okay. Right, we loaded all these up here. Okay, so our train queue of stacks. We have a new stack. We're going to split our train items here. So item currently is 2. That's my destination train now is 2. We're going to add that to the stack. If the length of the stack is more than 5, do something. It's not. Nothing else to do. Grab the next item. So it's 2, 2, 2, 1, 3. So now the length of my stack should be 5. We're going to enqueue that stack and then make a new stack. Here's my stack. Had a bunch of items, right? It had the node. The top item here was 3, right, which is good. Now we have a new stack. The top is none. Next item is 2. Add it to the stack. 2, 2, 2, 1, 2, and then it should add that stack to the queue, make a new stack. Nothing else in here. The length of the stack is not 0. Enqueue. Okay, so we should be okay. So now we have a. This is my train items, right? Self dot train queue of stacks. It has a back, it has a front. So the front node has 5 items in it. The top is a 3. That's what we expected, right? It should have been that first 3 here. That was the first stack. It looks okay so far. All right, so this is okay so far. So we'll go back to, we'll just let it run to load items. All right, if the length of our train queue of stacks is not 0, keep on going. If the length of the front item is not 0. Did I step too far? Oh, broke. What's the front item? The front item should have been train queue of stacks. The front item was a linked stack. Our items was 5. Why is it not like that? It's unhappy. The front item should have been a stack, right? We can do length of that, right? Then we add length, self number of items, train queue stacks, front. Oh, the name here is why. So we have a front method and we have a front attribute. Q was broken. Right, this should be self underscore front. Let me actually undo that. Let me refactor rename that. That'll take care of that issue. Didn't we run into this before? I think we did. Front. And back should be private as well. We'll clean this up here. Back. All right. Now I think this will run here because that's why I said it wasn't callable, because it was the front object, not the front item here. Maybe. No. Okay. Still failed. Oh, no, we don't want to call underscore front. All right. I refactored the wrong thing. One more time. Hey! All right. 25, 36, 3, 65, and 50. Is that what we got? All right, a little bit of debugging. We got the right output. And again, if we change other values, we give it different numbers. Like if you tried with no planes or no trains, right? We should have just gotten back nothing here. So if we get rid of all the planes here and have no plane items and run it again, it should still work. Right? We get just the trains, right? Or if we give it just the planes, undo. So we get rid of the trains here. Copy that and run it. We should get just the planes. Cool. And if we change some of these values up and gave it different numbers, right, we could have different results. Should do that. I don't want to go through and do all the math, right? But should be okay. Does that make sense? Awesome. Now let's just add like one more item here. So let's add one more to train number 2, just to make sure we get that partial stack. Right? And now we have 40 instead of 36. Right? Took another 2 minutes at the end. For 2. Yeah, because this was 2 more minutes to get back would be 38, 2 minutes to get there would be 40 for train number 2. All right, I think that math checks out. Questions, thoughts, concerns? Again, using classes here is completely optional. I like classes because it reduces the amount of code I have to write. My guess is it probably took you more than 76 lines of code to do yours. That's just a guess. Just a guess. I haven't looked yet. And we do it in less? Not that lines of code is the only way to measure things, but it's an interesting metric sometimes. No? Okay. Let's just one approach here. Yeah. Did anybody use classes at all for trains and planes and things? Yeah, you did. Okay. I think you needed classes, right? Oh no, I didn't even say. I used two classes. Okay. I always giving you points for it. Did you have separate ones for plane and separate ones for train? Anyone have a dock class? Yeah. No, that's okay. Just one way of doing it. Like that kind of organizes everything. It could have just been in main as well. Like that is just the main method, has all these values and has the trains and planes. So that's all. Awesome. So let's talk about the next project then. This is using linked objects, so not linked lists here. This is our linked objects. This linked, it's not links of term nodes is more proper here. So the idea here is that instead of using a linked list that just holds anything, we're specifically using a class called term node, which will store the next term node, and 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 the next term node here. So the idea with a polynomial is it is n number of terms, really one or more. If you have none, you're not really a polynomial because there's nothing there, right? But we'll have at least one term. So to create a polynomial, you'll have to give it the exponent and the coefficient. I should name those better here. I'm feeling bad about those. So this is exponent and coefficient. And actually, it probably should be the other order, right? Like the coefficient, then x. So let's do that. We'll fix that. So coefficient and then exponent here. And did I do that right then? So coefficient and exponent. Okay, yep, I did. I had it backwards in that explanation. So you can make a polynomial for a given coefficient and exponent. And then you can take two polynomials and add them together. So we're going to override the add and the multiply operations for this class. So I can take some instance of polynomial plus another instance of polynomial and get a new result back out. Now, it's important at this step here is that the originals don't change. If you think back to math, if you say 2 plus 3 equals 5, you haven't changed 2 and you haven't changed 3, right? Those stay as they are. What you get is a new integer result of 5. Same with polynomials, right? So I'm not changing the polynomial. I'm giving you a new polynomial back when you add and multiply, right? For differentiate, we're going to give you back a new polynomial. For integrate, we're going to give you back a new polynomial. Just assume 0 is the constant. We don't have to worry about any of the actual math stuff here, right? So for differentiation, right, we're going to take the exponent down by 1 and multiply. For integration, we do the opposite, right? Multiply and then, or divide and then add the exponent. You can assume we won't do dumb things with integrating when, or differentiating when the exponent is 1, right? Because you get nothing back, right? I think all of these examples avoid all of that. That just makes a mess here. And we're not going to integrate anything at -1, right? Because that'll also make a mess when we're done. So just assume that it will be okay. We don't have to handle all those special edge cases here. But the idea is a polynomial is the outer class we're going to interact with. It has its own inner wrapping here around term node to store each individual term in the polynomial, right? It has its own exponent, has its own coefficient. Now, exponents we can assume are integers. It'll make life easy for us, and coefficients should be floating values. Right? You can have any value for the coefficient here, right? and as we start dividing and multiplying, obviously we'll need that. And then you'll want to see if a term node equals another term node, or if it does not equal another term node. So we have to override the equals and not equals functions here. And then in polynomial, right, it'll have its first node, its first term here, and then when you make one, right, you give it the coefficient exponent because you have to be at least one term to make a polynomial. We can add polynomials, we can multiply polynomials, we can differentiate, we can integrate, and then we can turn ourselves into a string, which will give us a nice string in descending exponential order, so highest exponent first, right, going on down. And in this case, we do want to clean up. If you give me something to the 0, right, clean that up. So, right, all we get is the coefficient at that point. So we'll have to handle that for strings, but assume we won't differentiate or integrate with the bad stuff, because that just makes life hard for us. But we can clean it up in a string version here at least. And then equals, does this polynomial equal another polynomial? Or not equals, does polynomial not equal another polynomial? Right? Now, remember the shortcut here? If you know if you are equals to something, you don't have to redo any of the logic for not equals. Right? You just say not equals this one, right? And you get back the opposite result, which is easy. So a couple ways to test this here for if you want to write some of these out. So polynomial 2, polynomial 3, right? 2x to the third, 3x to the fourth. If I add them together, I'll get a new polynomial result of 3x to the fourth plus 2x to the third, right? In descending exponential order here. And if I print it, right, I should get back the nice result here. And then if I want to make a new polynomial 3 of polynomial 2 times polynomial 1. So we're going to change what 3 used to be. It no longer be 3x to the fourth. We'll get poly 2, which is 2x to the third, times this new one here, which is 3x to the fourth plus 2x to the third. Right? So for every term, you multiply by every other term, and we add them together here, right, when we do our multiplication. So we should get back out 6x to the seventh plus 4x to the sixth. Right? And then if we want to differentiate that, right, now we'll get 42x to the sixth plus 24x to the fifth. Or if we want to take polynomial 1, which was 3x to the fourth plus 2x to the third, and integrate it, right? Divided by, and then raise our exponent, 0.60x to the fifth, 0.50x to the fourth. Right? I think the math checks out for these. It's been a little while since I did calculus. This is pretty basic stuff though, right? So for points for this, right? Having the term node class, 3 points. Having the add function, 3 points. Having the multiply is 3 points. Differentiate, 3 points. Integrate, 3 points. String, 3 points. Equals and not equals is only 2 points because that adds up to a nice even 20. And these ones are not, like once you've done equals, not equals, it's just the opposite of that. It's not too bad. So interesting pieces here, right? When we are adding polynomials together, right? If they have the same exponent, what do we do with our coefficients? Add them together, yeah. So if they're the same, so what we have to do is we have to go in order to work these things out with all the terms. I should have brought my tablet, man, I forgot. I almost grabbed it too. So if we have, give me like two exponents, like two polynomials, sorry. 4x to the third. Why is it highlighted there? Okay, 4x to the third and 7x squared. Okay, so now let's add another polynomial, or add another polynomial to this now. So give me something that has a third or second power. 2x squared. Okay, so if I'm going to add this one together, so we'll call this one P1 and this one P2, right? Inside the polynomial, we have the first term, we have the first term. So I'm building out a new polynomial result, right? So I'm going to get a new result here. My result then is going to be equal to something new. Which term is going to go first? What do I have to look at to decide which one's going to go first? The exponent. So which one of these has a larger exponent? The top one. Okay, so we'll just take the top term. So two things could happen, right? Either the first term will have a larger exponent, or the second term will have a larger exponent, right? Meaning they're different. Or if they're the same, we do something different. So if they're not the same exponent, take the larger one. Right? So this is 4x to the third. And then remember when we did this walking idea? Right? As I take the first one and then I walk to the next one, and what's current, what's current, what's current, what's current. You got to think back to linked lists. I know it's been a little while since we did them here. Right? So we were looking at this one here. Now we go look at this next one. We walk to the next term. Right? So now the first current term and the current term, do they have the same exponent or do they have different exponents? The same exponents. Okay, so what do? Yeah, we add the coefficients. So now we have 9x squared, and now they both walk. This one goes to this next. This one goes to this next. They're none. If they're both none, we're done, right? This none here, it's none, we're done. What if they're not none? Right? What if we had another term over here? What if we had 7x to the first? Well, the top one is none, and this one is not none. So can I say which has a larger exponent? If you try and ask none what its exponent is, bad stuff's going to happen, right? Because none does not have an exponent, so it'll crash on you here, right? So if it's not none, then we compare the exponents. If it is none, we just start adding the one that's not none, right? Once we hit none on one of these, you just keep on adding to the rest, right? As many other terms, we could have like 2x to the negative 3 and on and on and on. We'll just take all the other terms here, right? We just start throwing them in here because we found the none. So the first thing happens while they're both not none, we compare exponents. Take the term and walk, take the term and walk. If they match, add the coefficients and walk both, right? And then just keep on going to the end here, plus 2x to the negative third here. So the other piece here, you don't need to worry about in strings is if you have a negative exponent, you can still say plus. That's okay. You don't need to change that to a minus something. Just plus the negative coefficient is going to be okay. It'll look a little funny, but again, it makes our life easier here. And we're not a math class. It's okay. You're not going to get marked down for doing plus a negative like I did in math class, which always drove me nuts. It's like it is the same thing, but it's okay. It's just more work. Does that make sense? So we're going to walk these links of terms. Each term node, if it has an next one, we do something. If it has a next one, we do something. If it has a next one, we do something. Now, that will add them in exponential ascending order, right? Multiplication is a little harder, right? So if we wanted to multiply these two together, this term times this term plus times this term plus times this term plus this term times this term plus this term times this term plus this term, right? We're going to have 6 terms, and some of them might have the same exponent. I don't actually know right now off the top of my head how that math works out. Yeah, 3, 6, 3, negative 9. Is that how that works? It's been a while since I did exponential math, polynomial math. But if you end up with the same term when you're doing your exponential multiplication, right, they need to get added together too. So there's a little bit of work that happens. Adding is a little easier than multiplying, right? Because multiplying, you have to do a bunch more things. So a couple extra steps there, but the same end result, right? Still all combined together, that sort of thing. Does that make sense what we're looking for this? Right, so I've got 2 weeks for it, so it looks like March 28th or so. So that puts us in our week on sorting and selection. So on Thursday, we can cover maps, hash tables, the same thing. We're going to skip lists. It's in the chapter, but it's in this advanced topic. We don't really care too much about it here. And we're not going to go super deep on maps and hash tables. We're going to do the easy thing. And there's a bunch of other really cool, smart things you can do that you can save for later. And then the week after, search trees. There's a lot about search trees, but again, we're only kind of scratching the surface here. This is a topic we'll get into later. So we probably won't take the entire time. Maybe just, I will see how far we get Tuesday next week. And then we can go over the project on 328. Sorting and selection will only take one of these sessions. So I think we can go over the project and start talking about the final project on 328. So that gives us almost a whole month then, from 328 to 425 to get it done. Ideally, we're done by 418. So that's 1, 2, 3 weeks to get it done, but we've got a lot of time set aside just for that. Like, I don't think ethics will take 4.6 either. Ethics is probably just 4.4. So we'll have some work time the last couple sessions for you folks to work. And this does need to be in partners. Right? This one can't be done individually because that is one of the outcomes here, that we learn to work together. Which is, it's not always going to happen in the real world. Like sometimes it's just an individual project, but it's really boring and lonely, right? It's much nicer to work with a team, at least to bounce ideas off of each other. So you can kind of talk through your thought process, talk through your design. If I think I'm going to approach my problem like this, because if you can fix a flaw in your design before you've written the code, it's a lot easier to fix. If you've written the code according to a bad design and then have to go fix it, it's going to take a lot more time to fix because you have to go back and change the code that you already have written. Right? So the earlier you catch these things in this process of designing software solutions or writing software solutions, the easier it is to fix. There's a whole scale of things, and you can learn about it like the software class. It costs even more money once someone's actually using it. Like if you give it to a customer and they find out that it's buggy and has a problem, it takes exponentially more money, time, and effort to fix once someone else is using it. Right? So the earlier we catch these things, the better. So teams are fantastic, at least just to bounce ideas off of each other. Even if you're not both working on the same code, a team is good for that. Now, ideally, you'll work on the same code together and kind of collaborate on it there. So we can use Git for that. It's a little bit funny if you both modify the same file. So we got to be a little bit careful there. So using modules will help out with that as well. And then once you have a commit, it's really hard to lose it. So if you get stuck in anything, I'm happy to help out, jump on a screen share and get you straightened out here, but it should work out pretty well. All right, so we are midway through March. We're almost done then. This is 11 out of 16 and a half weeks, right? 17 weeks if you count this final semester week. Questions? I think everyone got the midterm in now. Okay, with the extended date, so I think we're good there. I'll work on getting those scored for you. I know I'm behind on the projects, I apologize. So hopefully with the rubrics, you know how you did, and there's not a lot of concern on those. We can go from there, okay? And again, that final project is the bulk of your grade. So that's, but you should know if it's successful or not, hopefully by the 18th, and feel good about it and not have a big thing hanging over. So, all right. Awesome, folks. You take care. I will see you Thursday then. We can get into our maps and hash tables.